Hey guys, welcome to another video. Now today we are moving on with linear relationships and we're getting into a little sub area of this topic, which is what we call coordinate geometry. And one of the early bits of this course that I want to get you guys thinking about is the idea of the midpoint or length of line segments. So these are two different types of things we can calculate with any segment. So that's just a line connecting two points. Now, I want to jump straight into some questions here and explain the concepts as we go. So I'm going to do one question from each. Now, in this first one, I'm looking at finding the midpoint M with coordinates x, y, which we're going to fill in, of the line segment joining the points 1, 0 and 4, 4. Now, I've gone through and actually drawn these in. So I have this point, I have 1 in the x, 0 on the y, so that's this one down here, and I have 4 in the x, 4 in the y, which is this one up here. Now, I want to find the midpoint of this line. So my midpoint is sitting, it's going to sit roughly, let's say, okay, here. Now, this isn't exact. I'm just drawing one in just to know what I kind of want to look for, right? So an important thing to note about all coordinate geometry and all things concerning the xy plane, this Cartesian plane that we defined in linear relationships, is the fact that this is a grid, right? So we have all these kind of infinite lines stretching through. That's why I've drawn this sort of on grid paper here on my app that I use to record these videos. We can see that there's this constant grid happening, and my x and y axes here, they're actually perpendicular to one another. And we see all the way through these parallel lines joining together. So everywhere along here, and as we work through these questions, this idea is very simple, but it ends up being really important and really useful. Because when we consider particularly the midpoint, we are looking at the parts that make up the midpoint. And that is going to be my x-axis and my y-axis here. Now, just to get you guys thinking about this right now, we can kind of see that this midpoint, if we stretched it down to the x-axis, if I drew this little line, let's do it in another color, that would help. Let's do this in green. Now, if I drew this line down to the x-axis and I drew this line across to the y-axis, I want you guys to think, where does this point look like in relation to both this x component here, this length here, as well as this y component length here? Now, to me, it looks like the point where it meets falls exactly halfway between these two. So if you were to graph this up as well on maybe Desmos or one of these better softwares, you'll be able to see this as well, that the midpoint of a line is the midpoint of both the x and y distances between each of these points. So you can see, for example, from this 4 and 1 on the x, I'm stretching from here to here. And my midpoint, the middle of my x, falls directly in between. Whereas here, in my vertical direction, from 4 and 0, my midpoint falls right in the middle of that. And those two x and y coordinates meet to give me the one smack bang in the middle of these 2 points in the segment. So finding the midpoint of a line segment is all about finding the midpoint between the x coordinates of the 2 points, the midpoint of the y coordinates of those 2 points, and they make up our point, our exact midpoint. Now, how do I find the middle of these two things here? Well, let me redraw my line here. So I have my segment, and I have a distance, say from the one x coordinate to the other, from this 1 to the 4, that is 3 units in length. So this thing here is 3 units in length. And up here, from my 0 to my 4, well, that's going to be 4 units in length. So stretching all the way up to here, that means I have 4 units of length. So how can I think about finding the exact middle here as well as the exact middle here? Well, think back to any other subjects we may have done. What's a good way to find the exact middle of 2 points? Well, if I remember back to statistics, the process of averaging out 2 points gives me a point right in the middle. Averaging out 2 numbers, so adding those numbers and then dividing them by the amount of numbers there are, that gives me something that is smack bang in the middle. So to do this, let's color coordinate this. So to find my midpoint at x, my x coordinate, so my midpoint x coordinate, I'm going to add my first value of x with my second value of x. And I'm going to average those two. So I'm going to do, and we write this as, say, x1 plus x2 divided by 2. That's how we would write this. So by x1, I just mean the first x coordinate. By x2, I mean the other x coordinate. And now we can just substitute in what we get. So I can add 1 and 4, and I can divide this by 2. This is the process of averaging this stuff out. And what I get here is an x coordinate of 2.5. And that kind of makes sense, right? Because if I travel from 1 to 2.5, 2.5 is the number directly in the middle of 1 and 4, because there are 2.5 units separating the midpoint from either side here. So finding the midpoint is all about just averaging out the 2 coordinates. Now, what about the midpoint of the y coordinate? Well, we're going to do the same thing. We're going to take our first y coordinate, add it to the other one, and then divide these by 2. So we get 0 plus 4 divided by 2. And 0 plus 4 gives me 4. 4 divided by 2 gives me 2. And that makes sense that this would be 2, because 2 is the number exactly in between 0 and 4. Now let me write this 2 in a different color, because that looks a bit jarring. Let's do that in green. So 2.5 and 2. Now this coordinate is the one right in the middle. And we can see that these two, if we were to draw them up until we meet this line, we would get a point that looks pretty much on my drawing, and it'll look a lot better on an actual software, is smack bang in the middle, right? This is a midpoint between this point and this point here. That is how we can go about finding the midpoint. Now let's talk about the length of segments. So if we go down, let's look at, let's say, okay, find the length of the segment joining the points Let's go -2 and 2, and 4 and -1. So I'm going to draw this once again. So I have the point -2, -2 and 2. That's this point up here. And I have the point 4, -1. -1. And I'm going to draw a segment connecting these two points. Now, this is a lot harder to think about, right? Before, with midpoint, we could kind of reason out a good way to think about it. But this is a lot trickier, right? So we have to go back to this idea of my perpendicular grid lines that stretch all the way along here. Now, if all of these grid lines here are perpendicular to one another, they all make these 90-degree angles here. Would you agree? So they seem to all make, the idea of anything perpendicular is that it makes a 90-degree angle. They meet at 90-degree angles. So my y-axis, oops, let's do that in another color. My y-axis and my x-axis, those also kind of meet at 90-degree angles, don't they? Here. So all of these little grid lines, you can even see on the grid paper, they all meet at 90 degrees. So what if I were to construct an imaginary line here and an imaginary line here? And these two, at this point, what angle are they going to meet at? Well, they're always going to meet at a 90-degree angle. Like so. Now, what kind of shape do we end up having? Well, we have a 90-degree triangle, don't we? And the longest side of this triangle is the unknown segment. So in the context of right angle triangles, this is what we call the hypotenuse, right? We can construct these imaginary right angle triangles, and my segment is my hypotenuse. Ran out of space. So what I need to be able to find this hypotenuse is I need this length here, and I need this length. Now, how can I do that? Well, I can simply just count. I can say that, all right, from this point and I want to look at, separately, the x and y coordinates. Because my x coordinate here, for example, in my first point, that is -2. And that goes all the way up to +4. So how many units have I traveled? Well, I've traveled from -2 to 0. So from, say, let's draw this in. From here to here, from -2 to 0 is 2 units. And then from 0 to 4 is 4 units. What's my total length? Well, I want to add these together. So my total length between my -2 and my +4 is going to be 6 units in length. Now let's look at the y coordinates. Because going from, let's do that in yellow, from 2 down to -1, how far am I traveling? Well, that length is going to be, let's go from 2 down to 0, that's going to be 2 units, and another 1 unit in the negative direction, so another 1. What's that total length? Well, once again, I'm going to add those together. So that gives me a total length of 3. And I'm just going to pop that into my grid here. I have a length of 3. Now, this is starting to look a bit colorful and ugly. So I'm going to redraw this, and you'll see that through just creating these lines and making a triangle, what we end up with is this thing here. Just a regular triangle, a regular right angle triangle from the segment we've constructed, as well as the two distances, lengths. I have 6 and I have 3. So I've just kind of gone from this one just down to here. I've drawn myself another right angle triangle, and I'm looking for this length C. Now, right now, the cog should probably be turning. Hopefully now you're able to link some ideas together. As you can see, maths is all related. So we see as we get further along in maths, there's a lot of crossover between topics, because where have we seen these right angle triangles before? Well, we learnt it when studying Pythagoras's theorem. So what does that tell us? Well, for a bit of revision, this tells me that a smaller side squared plus another side squared equals the third side, the longest side, the hypotenuse, squared. And some of you may remember this as a squared plus b squared equals c squared. That is our Pythagoras' theorem. So when we do this calculation, we get 45 equals c squared. And we can find the length by just taking the square root of both sides to find what c is. And we end up with the square root of 45 equals c. So c is approximately, let's do it to 2 decimal points. C is approximately equal to 6.71, so 2 decimal places. Now, in finding any length of a segment, we are always constructing these right angle triangles and using Pythagoras' theorem. With midpoint, we thought about averaging 2 coordinates to find an exact midpoint. With finding the length of a segment, we are taking these points and joining these corners and making right angle triangles. Once we construct these, we can just find each individual length, but it's just a matter of counting. That's all we have to do. Once we have those there, we have a right angle triangle, and we can apply Pythagoras' theorem to find the length of the hypotenuse. Now, with these line segments in coordinate geometry, in linear relationships, we will always be finding this C. We'll always be finding our hypotenuse. But that is how we can apply these methods to finding both the midpoint and the length of a segment. Thanks so much for watching, guys. I'll see you in the next video.